that button, this button. There we go. All right, good morning, everyone. Whiteboard has all the due dates and stuff coming up. So 2.1 is due today, my math lab homework. 2.2 is going to be due on the 29th. 2.3 will be due a week from today if we finish it today. It's another case of we've got a decent amount of material to cover, so whether we can cover this in one day or not, we'll find out. Your next Excel file that's due is the 26th. Remember, I had a little mishap with the due date. This was supposed to be due today, but I said I originally wrote the 26th, so I'm giving you the extra couple days. So really you have until Saturday at midnight. Don't expect this to be a usual thing. That was just a goofy mistake on my end that I figured the couple extra days won't hurt you right now. And then we will have a discussion board today, the one that I thought I was going to have ready for last class. We'll have ready for this class. All right. Before we get into the actual material of the day, I have kind of finished working on this grade book that I was talking about with y'all last time, I believe. And I'm going to be distributing this to everybody without any grades in place, so everything will be blanks or zeros. And the yellow spots here, 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 and then these 4 spots are where you will put your grades in. Over here is a column saying what each category counts as, its weight. And then in this spot here, it's just grabbing the averages or the numbers from over there. So whatever number is displayed right here for the average of my math lab, I just then collect it and put it over here to be organized. Whatever is right here, your average for your Excel homeworks, I then collect it over here. It's just a cell reference. Same thing here, whatever you see here will be there. So watch, if I just manually change this to say 4,000, now that says 4,000 and nothing makes sense anymore, so we undo. But you can see the direct correlation. Same with the participation grade, project, midterm, and final. Now, you will note over here that it says we have zeros on the project, midterm, and final, and that's because these are blanks over here. But I have got this extremely long formula to calculate your grade, and it's this right here that is the entire reason that I said I'm not really into making this a project anymore, because Excel's got this weird issue with some products and data values that aren't there. You'll see these little if statements and these things I am not going to explain to you right now. It's a really cool way of kind of like having a switch, an on-off switch. It's basically saying if something's not there, so oh, there's no grade in the project, then that means I got to undo because I clicked something. Because there's nothing written in the project, it's not going to count that 5% in the bottom, and it won't affect your grade. So even though it says I've got zeros here, you can tell that the final grade is not affected by that. Without those little if statements, it would be. So again, you don't have to come up with this formula. That's not the point of this. The point of this is for you, the student, to keep track of your grades. Now, this is a calculation you should be able to do by hand, just straight up, but this is a great way to keep things organized so you don't have to constantly do that all semester, because who wants to do that? So you will manually put in your My Math Lab grades as you get more and more and more. And as you get more and more, your average will change. Watch this 90.5. Hey, 1.3, I got a 100. So that 90.5 should go up. And it does. And 2.1 I didn't do, so I get a 0 on it, and my average goes way down. And then the next one, oh, I gotta make up for this. So the next several I get 100s, and my average keeps going up. And then if my Math Lab average is going up, my final grade average is going up. Same with Excel, same with quizzes. So each of these yellow columns, this down here is just a straight up old school average of everything in that column. But it's set up, look when I double click this, it highlights all of them, not just the ones that we've completed. That way, as I enter more and more grades throughout the semester, it updates. Oh, I got a 95, updated. Oh, I got a 71, updated. Also remember that I said that I will give you up to 10 points for each My Math Lab assignment. That's the only category, pay attention. It's the only category I do that for. I will give you up to 10 points. If you don't do an assignment, if you got a 0 on it, it stays a 0. If you got 100, it stays 100. So I'm only going to give you up to 10 points. I will not allow any grade to be over 100. So if you earned a 91, then you type 100. If you earned a 95, then you type 100. If it says you earned an 81, then you'll type 91. So again, all right, I do my project and you know what? I didn't do my project. Ooh, that's bad. I need you to watch this really closely, okay? So I'm gonna type a 0. Watch this final grade. That average should go down, but it doesn't. And that's what this memo is about right here. If you have any category that you actually earned a 0 across the whole thing because you didn't do it, you will need to temporarily overwrite the value as something like a 0.1 to see your true grade. So I did not do the project, which means I earned myself a 0. But because of the wackiness of Excel and those things I was talking about, if you put a 0, it thinks it's blank, which means it's not actually accounting for it. So if I didn't take the midterm and I earned a 0 on it, if I didn't take the final, I earned a 0 on it, it still says 90.45. This is actually the same issue as my math lab has. And it's a very difficult issue to get around, even with those little if gates. So the simplest way is to just make that category like a 0.1, a very, very small number, 0.1, 0.2, 0.001, whatever you want to say. So I basically just stopped working in this course. It looks like I didn't do the project, I didn't do the midterm, I didn't do the final, and the course is done. My grade's definitely not that. So watch what happens when I change this final exam to something like a 0.1. Watch my final grade number now. Ooh, 66. So now it's really counting that. And a 0.1 is close enough to 0 to be super accurate. Even if I make this 0.00001. So watch, this is probably going to go down like a 66.34, 32, I don't know. 3.3, I was in the ballpark. So is there really a difference between a 0.3 and a 0.4? No. So this is just something you'll have to temporarily do. Now, you need to undo that though, because if you then, let's say you originally didn't do any quizzes, so you said, all right, I have a 0 here, I need to put that 0.1 here so that everything accounts for it. But then if you actually did start doing your quizzes, this number right here is still going to be the 0.1, and you will have overwritten the formula that I created. So that's why I say temporarily, which means after you do that 0.1 and you see your true grade, you hit undo. That way, those formulas will all still be in place. See, average. If I manually type that as a 0.1, it no longer says average. It's no longer doing anything here. So if I did assignments later, it'd be screwed up. And then you're going to email me and say, Mr. Beckner, can you send me the file again? And I'm going to say, no, you should have paid attention to the instructions. Also, you could just download the file again from the email. So this is why we don't delete our emails from our teachers, because important documents are in there. Okay, so again, I'm going to be emailing this to everyone. I hope that's an excellent resource. I spent a lot of time putting this together, so I hope you appreciate it, and I hope you never ever email me asking your grade. Because what do we say? We teach you to fish, not give you a fish. Okay. And this is also something that you could play around with and actually redevelop for another class if you wanted to. So if you had a class that only has regular homework and then 3 tests, you could just rename this Test 1, Test 2, Test 3. You'll have to change the percentages, maybe delete a category, but there are ways that you can adapt this for any course. Okay, so back on track, 2.3. And let's not show everything all at once. And I did want one final reminder. This is about the 4th or 5th time I've put this on the screen. I know I've said it a lot. But remember, for those fixed cell references, something important for that BMI assignment, something that you should have made an addition or multiplication table to set that up. And warning, if you're not going to do this next Excel file, if you haven't turned any in, you're going to be getting emails from me in regards to this. This is unacceptable. You're going to have to do something at some point. So you fix the column by putting a cash symbol in front of the J. That means that that reference won't move left or right. It's stuck in that column. You fix the row by putting the cash symbol in front of the number of the reference, which means the height will not change. The reference will not move up or down. If you don't want that cell reference to move at all because it's just some random thing off to the side, then you fix both of them. So again, kind of the final reminder of that. Now that we will have turned in the BMI and practiced with the creating an arithmetic table or multiplicative table, I don't think I need to say that again. In terms of teaching. All right, so 2.3, proportionality. something that we already spent a good amount of 2.1 talking about. We talked about how proportions are just fractions set equal to each other. We also said another word for a fraction is a ratio, a top and a bottom. We said that it's a really good idea to be using our words to, before we start writing the proportions out, write apples over oranges. If we were using a proportion table, that seems less important, but it still might be a good idea. It's up to you. But we're going to go into extended concepts of proportionality. So I've already kind of spoiled this bolded note several times in the past, and that's that if two things are in the sense of what we've said so far proportional, which really means directly proportional, it's kind of an extra word you're supposed to throw in there, but most people don't if it's directly proportional. Kind of like if I say it's 70 degrees outside right now, what I'm really saying is it's 70 degrees Fahrenheit. A lot of times when we speak math, we drop some words because they're understood implicitly. It's implied. So all the types of proportionality we were studying back in 2.1, we're saying that if they were directly proportional, we just said if they were proportional, then if one thing doubles, the other thing should double. That is the base concept of direct proportionality. We've also discussed how not all pairs of data are proportional. So in the real world, you are likely to have to ask yourself if that previous statement holds true or not. So if you were to double one, does the other have to double? So what this leads into is the group work that you'll have to do. Excuse me. Is right here. All right, so this is page 86, 87, yeah, 86 and 87. And you can see there's 15 questions. So that'll give 15 students opportunities as a base, but if the first student comes in to answer question 3 and and someone else thinks they answered it wrong, then another student can come in and do a threaded response and say, well, I don't think your logic to number 3 is right. Here's what I said and here's why. So again, just because it's 15 or 14 or 13, whatever questions, doesn't mean that's exactly how many students have an opportunity. You have an opportunity to come in and say, yeah, I really like what you said. Or you have the opportunity to come in and say, no, I disagree with you. And quite honestly, there should be disagreement. If we were doing this in class, I always do this assignment in class, and there's always tons of disagreement, especially with ones like number 2 and 4, there tends to be disagreement. Number 7, there tends to be disagreement because they don't want to keep this as a simple concept. I'll explain what I mean there. Number 9, there's a disagreement. Number 12, there's always a lot of confusion because of the phrasing of it, but honestly, it's the same exact question as 11. It's just sciencey sounding. So what are we doing here? Determine which of the following quantities are proportional. And again, someone might say yes, and then you come in and say no. But don't just say yes and don't just say no. Especially if you're responding to someone in disagreement, you need to say why. I don't give credit for just a no. No, and this is why I feel that way. Have a conversation like we were in class. I tried to do some more traditional group work with my MDE class the other day. I know 1 or 2 of you were in there, and I don't think it went very well because of, some people are sitting at work, some people have their kids around and stuff. So as much as I would love to do that, I think I am going to stick to the discussion boards for the semester. All right, my side discussion aside, determine which of the following quantities are proportional. Now this down here, this intuitive definition, I'm not going to make that a question for someone to answer. 2 quantities are directly proportional if when you double one quantity, the answer to that was literally just in the notes on the other screen. If you double one quantity, the other must double as well. That's what it means for 2 things to be proportional. My internet has been a little weird this morning, so if there's any audio issues, I'm going to apologize for that. Hopefully it won't be consistent. Yeah, always fun. I was a little worried about that when my phone, the Wi-Fi signal kept going out about 20 minutes before class. I was hoping it got that out of the way. Okay. And what I've found that is when the audio is lagging, a lot of the times the YouTube recording won't be laggy, at least when I've done the review. If I'm wrong, someone can correct me on that. But if there's ever a time when I'm just laggy the whole time, go back and check their YouTube video, and hopefully it's right. If not, shoot me an email. I won't record a whole class, obviously, but maybe we can figure something out. All right, back on track. The first one has already been done for you, so no one gets to answer number one. Number one is already done. Property tax and appraised value of your house. So this is what you need to do in your heads when you're answering yes or no. Ask yourself, and you might have to think about this as a two-way street. If you double one thing, does the other thing have to double? And asking, if I double the first, does the second have to double? That might not be a logical flow, so maybe you need to ask the question the other way. If I double the second thing, does the first thing have to double? So asking it first, then second, and for number one is a little weird. If I double the property tax, does that mean that the appraised value of the house has to double? Well, that sounds a little weird in terms of how that thing really works in the real world. You should actually ask the question the other way. So you, like I said, you might have to ask it if the first, then the second, or if the second, then the first. All right, so the first one didn't quite make sense. So let's say if I double the second thing, if I double the appraised value of the house, does the property tax on the house have to double? And if you know anything about real estate, which we don't expect you to, which is why this one's been answered for you, yes, if the appraised value of your house doubles, your property tax will double. If all of a sudden the city of Portsmouth says that your house went from $100,000 to $200,000 because of this housing thing going on right now, you better sweet believe your property tax bill the next year is going to double because they want that bread. So they didn't just say yes, they said, all right, doubling the value will double the property tax. So again, doubling this thing causes this thing to double. It's cause and effect. Sometimes you can think of it either way. Sometimes that logical flow is only going to work one way. So for question two, when someone comes in and answers yes or no and says why, they could say, all right, if I double the population of a region, does that mean the area of the region has to double? And they might say, well, okay, yes or no, and I'm not going to answer anything about that. But what they might instead have, if they think that that logical flow doesn't make sense, try it the other way. If I double the area of a region, does the population have to double? And I think you can actually answer that one either way. If you're having a hard time with number two, think about places like New York City or Suffolk and how they're drastically different, and how, you know, if you expand, does that force the population to increase? Or if you increase the population, does that mean you have to acquire more area? Volume of gold and weight of gold, there is some type of relationship between volume and weight. I won't say whether it's proportional or not, and I'm not trying to make it sound more complex than it is. But there is a pretty simple argument between number three. Population of New York City and population of New York State. So if you double the population of New York City, does that mean the population of New York State has to double? Or maybe you need to ask that question yourself, vice versa. Question five, pretty self-explanatory. Question six, think about these tickets are all going to cost the same price. So you're going to the movie theater and it's matinee time, and they don't care whether you're a senior, college, whatever, everybody pays one price. So think about that scenario. Height of a photo versus a width of a photo. This is one where a lot of people could say no, because they could, oh, I can just make this photo as wide as I want, and then your face looks all wacky in it. No, what we want to do is maintain something known as aspect ratio. And that last word I just said is a massive hint about number 7. Aspect ratio means that if you make it wider, you're also going to have to make it taller so that the faces don't look all wacky when you reprint them. So think about, all right, you get your graduation photos, you can get your 3x5s, your 4x6s, et cetera, but you always look pretty much the same in those, right? Okay. Number of accidental deaths in 2005 versus number of motor vehicle deaths. This one right here is, some people will get this wrong, but think about whether these two things are absolutely related to each other or not. Accidental deaths doesn't just mean motor vehicle deaths. This could be someone falling off a building or getting struck by lightning, things like that. cups of sugar to cups of flour in a pancake recipe. So in grandma's wonderful pancake recipe, that when she makes them, if she's just making pancakes for you, they turn out the same way as if she's making pancakes for the whole family Christmas morning, and she's got to make 50 of them. So think about it that way. They got to turn out the same. Your IQ versus your GPA. I have one word that I'll say that spoils this one: laziness. All right, distance to work versus time it gets to work. Don't think about traffic and different paths you can take. Keep it simple. Number 12 is literally the same thing as number 11, even though it sounds a lot crazier. Distance of a celestial object and the speed at which it's receding from us. Just change celestial object to car and the speed at which it's moving away from us. Okay? Euros to dollars, currency exchange. We're going to be covering an entire section that kind of bases off of this. And it goes into proportional relationships, spoilers. Sea level change versus the amount of ice melted from glaciers and icebergs. This might be a more challenging one. I don't want to spoil the answer. Maybe Google something about that if you think that it is proportional, or if it's not proportional, but I'm not exactly expecting this one to be right, but have a discussion, have a good discussion. And then miles you drive versus gallons of gas you use. Again, keep this argument simple. Don't think about interstate driving versus city driving versus someone slamming on the accelerator versus someone using their single toe and just barely hitting the accelerator. Keep it simple. Keep these scenarios simple. All right, so that is your discussion board, page 86 and 87, questions 2 through 15. Where am I trying to go? Here. Page 86 through 87, 2 through 15. All right. So back to our notes. So again, if one thing doubles, the other thing doubles, that's direct proportionality. But we're going to study other types of proportionality besides direct. But let's focus on direct for now. You can set up a proportion to find the constant of proportionality. This constant of proportionality, yes, and you're each doing one question. This constant of proportionality is the number that says, all right, for every one apple, there's 5 oranges sold. In that instance, the constant of proportionality would be a 5 because it's a 5-to-1 relationship. If we said for every 10 euros, you're going to convert that to $1, that is not the true conversion. I'm just making things up. For every 10 euros, you get $1, then 10 would be the constant of proportionality. It's the thing that you can multiply one of these values by to find the other. Now, I didn't say it works both ways. I said one of them. So there's actually, for each pair of apples versus oranges, there's 2 different constant of proportionalities that you could end up discovering. So in that first instance, I said it could be 5. It could also be 1/5 if you set up the problem different from student A. Now that only works with direct proportionality, and we will illustrate in writing what I'm talking about later. So K. K is the first letter of the word constant, right? LOL, I know, it's just a hard K sound. But C, it just isn't our favorite variable to use because some people get a little squirrely with their C's and they start looking like O's almost. So I don't know why I don't have it maximized. There we go. So when we talk about the constant of proportionality, the thing that says, all right, for every one of this thing, there's that many of the other thing. That's what we call K. So with these proportions, you can set up a proportion. When 2 things are directly proportional, you can set up fraction equals fraction. We've discussed that in great detail. We've done numerous examples. But there is another way to set them up, and that's what we're staring at right here. Instead of setting up fraction equal to fraction, you can say, all right, if 2 things are directly proportional, if y varies directly with x, so if the oranges vary directly with apples, or if the euros vary directly with dollars, anything like that, if you're told that, or if you've deduced that, then you can write the equation y equals kx. Instead of using Y and X, you could use more appropriate letters like E for euro and D for dollar. That's certainly up to you. But we do generally keep the letter K for that constant of proportionality. Now, what you'll be doing is you'll first write this Y equals KX. Then you will plug in the first scenario. First case, so like if there's 2 apples, there's 10 oranges, so you'd plug the 2 in for whatever you called apples, the 10 for whatever you called oranges. You solve for K, and then you rewrite the equation. EQN means equation. EQN means equation. So the first thing you'll write is like Y equals KX, if you think 2 things are directly proportional. And then to the side, you would say X is the number of apples, and then Y is the number of oranges. Maybe you decide to call them opposites of each other. You call X the oranges and Y the apples. That's okay. There's nothing wrong with that for direct proportionality, thankfully. It can be for more complicated ones. And then maybe I say, all right, for every 2 apples, 10 oranges sell. So what you do is you make the apples 2, which was X. So we go K times 2. The oranges are 10, which is the Y. This is why we write things like this. This is super important. Otherwise, you might put the numbers in the wrong spots. And then you just take this equation and you solve it for K. K times 2 means you would divide both sides by 2. You don't even need to rearrange it. You can. That's up to you. And what you would get is 5 is equal to K. That says for every 1 apple, 5 oranges sell. Now, it's not the other way around. It's not for every 1 orange, 5 apples sell. That would make sense because it was 2 apples to 10 oranges. So you've got to make sure that you make that statement in the appropriate order. So then what I could do after that is say, well, how many oranges sell if 101 apples sell? All right, so we had a really small store initially. We only sold 2 apples and 10 oranges. A year later, we've expanded our store. We're a grocery store now, and we sold 101 apples in one day. So what you do is you take your equation, that Y equals KX, but you plug the K in. So we go Y equals 5X. We took this, but we plugged in this number to get this. Because that K value, that 5, will hold true for every single scenario as long as these are proportional. Oops, too far. There we go. So if we sell 101 apples, what do we say apples is? Apples is the X. So we go Y equals 5 times 101, which is 505. Now the answer is not just 505, it's 505 oranges. If we sold 101 apples, and this whole concept was that they were proportional, that means we sold 505 oranges. Okay, so we're going to come back to this idea in this example down here. We're going to do one just like that, but I've got it set up. I didn't just pull the numbers out of thin air. But before that, I want to describe the other types of proportionality that you can see in the real world. Not everything in the world is directly proportional. There are tons of things that are directly proportional. Assuming that you continue driving at the same pace with the same acceleration, or the same pressure on your accelerator more specifically, then if you put 2 gallons of gas in your car, you might be able to go a certain distance. If you put 4 gallons of gas in your car, you'd be able to double that distance. Every time you double the amount of gas you put in your car, you'll double how far your car can go. So that would be proportional. But there are things in this world that do not double as one doubles. So one thing might double and the other thing might half. That's the idea of inversely proportional. So there's an extra, or excuse me, a different extra word in front of the word proportional. So if I just say the word proportional, we assume it's what? Direct proportional. But if you throw extra words in there or different words besides direct, it changes the equation. This is not y equals k times x, it's k divided by x. So what this means is, as one thing goes up, the other thing's going to go down. More specifically, as one thing doubles, as x doubles, y halves. Or you could say as x triples y, it goes down by a third, that kind of idea. There are plenty of things in the real world that are inversely proportional. Hold on, give me 15 seconds. Sorry, someone's doing something. Okay, so let's say you need to cover 10 miles. So you know you've got to cover 10 miles. If you increase the time that you want to accomplish that drive in, if you want to increase the time that you want to accomplish that drive in other words, you want to take a longer time, that means you're going to have to slow your speed. Or no one really wants to do that. We're not usually casual drivers, right? So let's say you wanted to decrease the time to make that drive, that 10-mile drive. If you want to get there quicker, that means you're going to have to increase your speed. So speed and time are inversely proportional for covering the same distance, because as one goes up, the other is going to have to go down. If you want the time it takes to go down, your speed's going to have to go up. Or if you want your time it takes to go up for some reason, nice casual long drive, you're trying to, I don't know, take an extra 30 minutes to get home because someone's going to fuss at you when you get there, I guess. I don't know. So if you wanted to increase the time it takes you to make that 10-mile drive, you'd have to slow your speed. So that's the idea of inversely proportional. As one goes up, the other goes down. Going back to the apples and oranges, maybe the store does a sale on apples one week and a sale on oranges the next week. So if this store sells apples for 10 cents, I bet the apple sales would increase in that scenario and the orange sales would decrease, because you're going to have a lot more people buying apples and they're going to go, well, now I don't need the oranges. So maybe there's an inversely proportional relationship there. So this y equals k over x. You will see a couple problems in the homework on this. We're not really going to be focusing on that in the Excel, although we have, believe it or not, seen an equation that uses this idea, but there was more variables in there. We, again, in this course tend to focus more on direct proportionality, but this does pop up every now and then, so understanding the concept's important. You can also have things that vary with the square of something. So when you drop an object from, say, the top of a building or wherever, as it falls, it speeds up. It speeds up due to gravity and the way gravitational forces work. So the distance that object falls is actually directly proportional with the square of time. Now there's the k in there is that 9.8 meters per second squared value, or 16 feet per second squared, whichever one you like. And there's some other little subtle numbers in there, but we don't have to worry about that. We're not getting into that. We're not memorizing that. So what I need to point out is, I said earlier that I wrote x as apples and y as oranges for this direct proportional problem that I just kind of made up on the fly. And I said that you could have labeled them backwards and it would have been fine. With inverse proportions, the same is true. You can decide to call x and y whichever you like. However, with more complex systems, like varying with the square of something or the square root or the absolute value, what you call x and y does absolutely matter. So you would have to make sure that everything is making sense as you're plugging in the numbers. Now, when we give you the sentences like this, y varies directly with the square of x. Here's the way it works. The thing that goes before the word varies, y varies, blah, 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 that tells me the y has to be on a side by itself. So I might say the number of oranges vary directly with the square of the number of apples. So I said oranges first before the word varies, so this y would have to be oranges. So the thing in front of varies is what goes on the side by itself. Write that down if you didn't already. So again, with direct proportionality, there's a cool feature that the y and the x are interchangeable as long as you're consistent. With inverse proportionality, same thing. But when you start throwing squares and square roots and absolute values, and you can even have what we call joint variation, so you could have apples, oranges, and bananas, then it starts mattering where you place what variable. Okay, so let's go back to a simpler one, direct variation. So the number end, I'm going to end up bumping this down on the next page to show my work after, but let's read it first. The number of students at a college varies directly, i.e. is directly proportional. So I'm just saying that the phrase varies directly is the same phrase, the same meaning as saying is directly proportional. So that's another word that you can use. The word proportional can it be exchanged with the word varies. So there's some important language to have to understand and remember as well. So the number of students is directly proportional to the number of courses. I think that makes sense. The more students you have, the more courses you're going to have to offer. That at least makes some type of sense. Does it mean that if you double the number of students, the number of courses you offer has to exactly double? Honestly, in the real world, not quite, but it's close enough that we're going to say it's proportional, at least in the sense of this problem. It's true as a base idea, but you'll get a lot of programs where the classes are always booked at 24 students each. Then you get those big lecture hall style classes with 100 students in a class. So glad I don't have to teach those. And then you get graduate level classes where there may only be 5 or 6 or 7 students in a class. So there's a little bit of play with that, but again, we're keeping the idea simple. All right, so when this college offered 75 courses, they ended up with 1,350 students enrolled. So they say, all right, well, we want the enrollment to increase because we want more money, so we'll offer more courses. You'll also have to increase your advertisement. Again, there's bigger picture implications here, but just go with the simple idea. So we're going to go from offering 75 courses to 100 courses, and we want to know how many students under this concept will we end up getting in here. So you can still certainly say, you can do this the old way. You can write a fraction equal to a fraction. Actually, I want to talk about that last. I want to do the new one first. But all I'll say is you can still use fraction equal fraction where you use words to set up your fractions and cross multiply, etc. But let's try the new setup first. So the new way, that's where we're going to write, well, we saw that it was directly proportional, so we can write y equals kx. That's the first thing we'll do. But we don't want to just do that. Don't you dare just do that. You better establish what is x, what is y. So x is going to be, let's see, the number of students at college varies directly to the number of courses. So since the first thing they said is students and then the words varies or directly proportional, the more common scenario is that that's what the y should be, just kind of going with what I said up here. We said the thing before the word varies or types of proportional, whatever, that's what should be by itself. So let's go with that, even though this is completely interchangeable. So students was the thing before varies or proportional, so that's what I'm going to call y. X then would be the number of classes. I will say this one last time before moving on. You can completely swap X and Y. Your algebra will look a little different, but you will ultimately end up at the same number of correct students if you didn't make any algebraic mistakes yourself. So X, I'm calling the number of classes. Y, I'm calling the number of students. That's how I chose to do it. Then they say when there's 75 courses offered, 1350 students enrolled. So let's plug those numbers in. So the Y was the number of students, so 1350 goes on the left. The K we are not plugging in, we don't know, that's the goal in this step. And there were 75 courses offered. We can just divide both sides by 75. Please feel free to rewrite that as 75K first if you have to. That is up to you. And if you do 1350 divided by 7, oh, I can pull out my calculator. I'm not on the silly mode. 1350 divided by 75. I was just going to say the answer, but here it is, 18. So that says that 18 is equal to K. Again, what that really says is for every, let me do this wrong first. Let me do this wrong and just see if it makes sense that it's wrong. So again, I'm pulling out the red for wrong for a minute. So for every one student, there's 18 classes, question mark. If you think about it in a real world idea, that doesn't make sense. For every one student, that college has 18 classes available. Well, I certainly hope that student's taken all 18 classes at least. So that means if you had 2 students, the college is offering 36 courses for a total of 2 students. So writing that statement definitely doesn't make sense. So let's get it right now. It really should have been for every one class, because it's for every one of the X value. That's the way it works. For every one of the X, there's K of the Y. So for every one class, there's 18 students enrolled. That makes a lot more sense intrinsically. So our equation becomes, our equation is now no longer y equals kx. It is now and forever, ever, ever for this problem, y equals 18x. The k is 18. That is fixed. It will not change. So now what we do is we plug in that third scenario. How many students would there be if the college offered 100 courses? Courses or classes, that's the x. So we're going to make the x equal to 100. So we get y equals to 18 times 100, which is 1800. The answer is not 1800. That is not a quantitative reasoning answer. It's 1800 students. Does that make sense? Well, when it was 75 courses, we had 1350 students. The number of courses went up from 75 to 100. It didn't quite double, so the number of students should not double. So doubling 1350 would be 2700. We got 1800, so that's less than doubling, but it at least did increase. It went from 1350 to 1800. So yes, I would say that makes sense. Okay, so what about the alternative way? So this was the new way. And what color do we like? Let's go orange. And I'm gonna need to do this. All right, so the old way, and by old I mean from 2.1, it's not that old. So the old way was where we write a fraction equal to a fraction, we cross multiply and we solve. But before we do any of that, we use our words. So what words seem to kind of help us talk here? We have students and we have courses or classes. So you could write students over classes, or you could write classes over students. My internet looks like it's being silly again. I'm gonna pause for 10 seconds and hope that that passes. Okay, fingers crossed. So again, the two things we're talking about are the number of students and the number of classes. You could use the word courses. You can put either one on top, either one on bottom, just be consistent. I'm gonna put students on top, and then I'm gonna put courses or classes on bottom. So when I write my fraction equal to a fraction, I got to make sure the student numbers go on the top and the classes go on the bottom. For each fraction, that's going to be a scenario that's paired. So when a college offers 75 courses, there's 1350 students. 1350 is the students, so top. 75 courses is the number of classes, so bottom. How many students would there be when the college offers 100 courses? So top or bottom, where's the 100 go? What's classes, so bottom. The number of students is unknown, so you can call it whatever letter you like. I call it X. You're going to cross multiply, and you'll get 1350 times 100 is equal to 75X. This is just a colon, by the way, which is 135000 equals 75X. You're then going to divide both sides by 75. And let's see what we get. 135000 divided by 75. Holy cow, we got the same answer, 1800. Oops, wrong color. What was X though? We should really say this is 1800 students. The same exact answer. So in the real world, does it matter which way you set it up? Nope. So why am I teaching you this new way then? Why don't I just teach you one thing? Because I love multiple methods, because multiple methods run this world. This y equals kx setup, this is awesome if you then had to go through another 200 or 300 scenarios. So maybe your boss says, all right, I want to know how many classes we need to run. I want to know how many students we'll have if we make 105 courses. Well, how about if we make 107 courses? What if we made 23 courses? Well, what if we did 1,000 courses? Well, you know, what if we made 7,902 courses? We're really going to expand. What if we only offered one course? So your boss comes to you and says, I need you to do these 10,000 scenarios. This cross multiplication would have to be done 10,000 times. That sucks. So this is not efficient. This y equals kx, once you have this y equals 18x, you could just type that in Excel and then use cell references and fill the formula down, and you would have all your 10,000 or however many answers I said within seconds, right? So this is about efficiency. Yes, you can still just do fraction equals fraction. It'll work all day long, but if you've got to do a bunch of these, it's not efficient, whereas the y equals kx is wonderfully efficient. Let me go one last time, and we're going to do this alternative new way. So I chose to do the x was the classes and y was the number of students. Let's still do y equals kx, but now I'm going to swap those. X is going to be the number of students, and y is going to be the number of classes. Let's see what happens if we do it this way, if we still get the same answer and what looks different. Okay, so we said when there was 75 courses, there were 1,350 students. So 75 courses, that's now the y, so the 75 goes on the left. The k times the 1,350 is now on the right. So you're going to divide both sides by 1,350 to solve for the k here. Now, when you do that, you're going to get some ugly decimal value, probably, right? Let's see what we get. 75 divided by 1,350. We get 0.0555. Don't write that for a k. That's a bad idea. What you should instead do, and it would be okay if this wasn't a continuous fraction, but it is. So instead, what you should just do is, okay, well, reduce them instead. And you could reduce the 75 and the 1,350 by 5 or by 25, all sorts of options. We already know that 1,350 divided by 75 is 18. So that means if I reduce this completely, what you'll get is 1 over 18 is equal to k, if you reduce that as a fraction. So then what that means is our equation is now y equals 1 over 18x. Look at this versus this. this is what happens, and this is not a problem. This is just what happens when you do your X's and Y's differently. If one person calls X the number of students and the other calls X the number of classes, one student's going to have their K be an 18 and the other would be 1/18th. Or for that 1 apple to 5 orange problem. So my K was a 5, but someone swapping what they call X and Y, their K would be 1/5 instead, or 0.2, since that's a perfectly fine decimal. So you might be thinking, oh, well, this isn't right, but it is, because your concept of X and Y flip-flops. So check out what happens when you plug in the 100 courses. So now what we do is, red. So we take our Y equals 1/18x, but we're going to plug in the 100 courses, which was the Y. So we get Y equals 1/18x. The way we solve this equation, the 18's in the bottom, so we multiply both sides by the 18. We're used to seeing 18 times x, so we divide. Well, if you see a division, you multiply. So those 18's cancel, giving you 1800 equals x, which is the number of students, the same answer. So we just did the same problem 3 different ways, and we got the same answer each time. One times anything is the anything. The 1 is still there if you really have to see it, but no one likes writing that 1. All right. Still not quite done, because I'm going to, I don't want to say that phrase. I am going to run this problem into the ground. So we're leaving the horse alone. We're going to run this problem into the ground. Let's show you one last thing. Using fractions to find the K. So we used the equation to find the K. We plugged things in and that was fine. We showed the old way where we did fraction equal to fraction, and we skipped finding out what the K is, and we just went straight to finding the number of students, which is perfectly fine. But you can still find the K using this fraction setup, but what you do is you don't plug in the second scenario's value. You just use this as your fraction instead and reduce it as much as possible. So you just use one scenario, that's a C, and your words, your labels. So you put courses over students, or students over courses equals, run through the first scenario, which was 75 classes for 1,350 students. And then what you do is you cross multiply, which will give you 1,350 courses times the number of courses, that's not 1,350 courses, equals 75 times the number of students. Make sure you know these aren't labels, those are basically variables. And then you can just choose to solve for one or the other. If you solve for courses, if I solve for courses, let me run this through first scenario. So A, solve for courses. So you take the 1,350 times the number of courses equals the 75 times the number of students. If you want to solve for the courses, you divide both sides by 1,350. We already know that fraction reduces to a 1/18, and you'll get, I ran out of room, didn't I? That's okay. I'm going to do that here. That's 1/18, so the number of courses is 1/18 of the number of students. Or the second scenario, so that says if you know the number of students, you can just plug that in here, multiply it by 1/18, and you'll figure out how many courses you need to offer. Or if I took that original thing and I solved for the number of students, which would have been more relative to the problem we actually had. So we take the 1350 times the number of courses, set it equal to 75 times the number of students. This time we'll instead divide both sides by the 75. And we know the 75 goes into 1350 18 times. So 18 times the number of courses should be equal to the number of students. And look how these same numbers ended up popping out. Those would be the K's in each of the scenarios. So in the first scenario, I've called Y the number of courses. In the second scenario, I've called Y the number of students based on what's by itself. That's your K. Again, just depending on which scenario you prefer, which one you prefer to solve for. For this problem, the right-hand scenario was easier, but for another problem, maybe the left-hand scenario was easier. Again, you don't need to master all of these different ways to do this. What you do need to do is understand how to do at least one of them, hopefully two of them. How are we on time? 15 minutes. I think we can do this. Page 92. All right, do this. Do this. There we go. Is that going to be enough space? There we go. All right, so this is page 92 of your guided activities. Let's see how many we can rock out in the time we have left over. And we'll just call it a section with where we stop at. And I've got things, I can't read the top right now, sorry. Given the following proportional quantities, so they told us they're proportional. We don't have to determine that. And again, in terms of my Math 5 homework, that's generally the case. You don't need to determine that. That's the real world issue. Determine the two equations, y equals k times x, representing the relationship. The first one has been done for you. So number one has been done. This is going off of the very last thing I did in our notes, where you write your fraction and then one of the scenarios, and then you cross multiply and solve for one of the variables. So what they did is they took the 9t equals 1v. They took 9t equals 1v. One time they solved it for the v, which is really already done. 1 times v is just v. I didn't need to change color for that. So 9t is equal to your v. So that's one of the answers, which was this one. I just have the sides swapped. And then the other one was you take the 9t equals 1v and you actually have to solve it. You divide both sides by 9. And you get that t is equal to 1/9 times v. So that's this one. It's a matter of which one you prefer to be solved for. If you have a problem where they're going to keep asking you for the v's, you want it to be solved for v. If you have a problem where they ask you for a bunch of t's, the tax, then you would want it to be solved for t. You want your equations to be as easy as possible. It means you want to be solved for the variable they ultimately ask you about. So they set t over v. So this was them using their words, tax over value. They said tax over value equals, and then they put in the numbers from the scenario they gave us. They reduced it just to make the numbers easier, and then they cross multiplied the t times the 9 and the v times the 1 to get this. And then the two, they said determine the two equations. That's where it's just one time you solve for t, one time you solve for v. Again, in the real world, there's no reason for you to solve for both. Pick one and stick with it. Which one should you solve for? The one they ask you questions about. Now, they're not asking about any questions in here, so that part's irrelevant, which is why they ask you to do both for good practice. All right, so let's come off of annotate, put this back where it was. Okay, so number 2. euros to pounds. So they say 113 euros gets you 100 pounds. So you could write, we'll do E for euros over P for pounds, not LB, that's a different type of pound. So we're deciding to go euros over pounds. I could have gone P over E, it doesn't matter as long as I'm consistent. Equals. Write the number for the euros, which is 113, write the number for the pounds, which is 100. There's no reduction here, so go ahead and cross multiply. After you cross multiply, you'll get 100 times E is equal to 113 times P. Then from here, you solve for either E or P. Again, if this was a bigger problem, maybe I say, all right, well, if we had 1 pound, how many euros would we get? That means it would be best for you to solve for E. Or if I say, if I gave you 2 million euros, how many pounds would that be? That means you would prefer to solve for P. So if you prefer to solve for E, you divide both sides by 100, which would give you E equals 113 over 100p. Or you could do it this way. You take your 100e equals 113p, and you instead divide both sides by 113 if you wanted to solve for p, which gives us 100 over 113 E is equal to P. Again, either of these could be the one you use. They asked for both, so we did both. This is literally doing y equals kx. Now you have y equals kx. You know that k is that 113 over 100 in this left scenario. E is the euros is what you've called y, and pounds is what you've called x. Or if you did it this way, again, the thing by itself is on the right, so that's the y, and then the k and the x. So k is the flip-flop of it. Euros is now x, and pounds is now y. That's the benefit of doing something this way. You don't have to think about the placement of things. That's why I'm giving you all these different scenarios. They're all awesome in their own way. All right. Number 3, the total cost of buying tickets to the number of tickets. So 6 tickets cost you 24 bucks is what this is saying. And if you buy more tickets, if you bought twice as many tickets, the cost would double because they're all the same price. So I'm going to choose to go cost for C for cost. I'll actually label my abbreviations this time. I'll be very meticulous. And then I'll do T for tickets. So I'm going to go C over T. I could do T over C, doesn't matter. Just be consistent. So make sure you put the cost of 24 in the top, the number of tickets, which is 6 in the bottom. Then we cross multiply and we get 6C is equal to 24T. You could have reduced that first. I honestly generally don't. There's nothing wrong with that. But this is just the way I do things. And then it's a matter of, well, if you want to solve for C, you divide both sides by 6, which would give us C is equal to 6 goes into 24 4 times, so 4t. That would be one answer. Or you take your 6C equals 24t, and you divide both sides by 24 instead. Now that does not divide perfectly, but it does reduce to 1/4. So 1/4 of the number, or sorry, of the cost of tickets would give you the total number of tickets you buy. So this would be the other version. Look at that, K was 4 in one scenario, 1/4 in the other. Finally, height of a digital photo in comparison to the width of a digital photo. So let's go H for height, and let's go W for width. See, I'm not using Y and X here because I have more appropriate letters, just better letter choices. I still could use Y and X. I could call Y the height and X the width, and then I go Y over X instead of H over W. It's your choice. Now, my math lab might tell you what letters to use, so pay attention. All right, so height over width, or width over height as long as you're consistent. Because I did height over width, I go 3 over 5. If you did width over height, you'd go 5 over 3. Cross multiply. So you get 5H equals 3W. Depending on which one you solve for, divide by either 5 or 3. If I want to solve for H, I divide by 5, which tells us H is equal to 3/5 W, or if I want to solve for W, I divide by 3. And I only, in the real world, only have to do one of these. So if my boss man gave me 10,000 different heights and wanted to know what the width should be, I would use this one. Again, if my boss gave me 10,000 heights or even one height, I would use this one because the W, the thing I want, is by itself. If my boss gave me 10,000 widths, I would use this one because the H is by itself, the thing I need. That enables us to use Excel to very easily type a formula once, fill it down 10,000 times, and boom, we go home in 15 seconds if we've got that skill sharpened. All right, so that is 2.2. 2.3, excuse me, silly me, 2.3, 2.3, 2.3. We finished it, which means we can assign the homework for a week from today. Today is the 24th, right? So that means it should be due on the 1st. So 2.3 is going to be due 10/1, remember, by midnight. Your Excel BMI is due on the 26th. What's your next Excel? It's 2.1, but I can't remember the name. Give me a minute. No, it's not 2.1. Wait, yes, it is. This says 2.1, but it's actually Excel file 2.5. We're going to be doing the one that goes with 2.3, and that's called 2.1. I know that's confusing. So it's 2-1 currency. That is going to be the next one due. This is not our shell. That date is obviously not for us. Please ignore that any dates you see up here. Please ignore any dates you see up here. I'm just pointing out what our next Excel is going to be. Currency, currency, currency. I'm going to say, what am I going to say? Let's have that due on the 6th. And of course, 5 attempts per usual. All right, so we've got all our assignments. I am likely going to be assigning another quiz in Tuesday's class, just to know you, just so you know, excuse me. And then that will be due on Thursday. So be prepared. There will be a quiz handed out on Tuesday that will be due Thursday, unless something changes. All right, so that's it. Email me if you have any questions. Hopefully in YouTube, the audio isn't messed up. I'm gonna check the recording after this, and I'm crossing my fingers that it's gonna be right. It should be, because the source, I'm very confident I've checked that before, and the source recording was fine. One of the few times where not watching live is better, I guess, but please watch live. All right, I'm rambling. Have a good one, everyone. Email me with questions. Keep working hard. Take care.